Students, sometimes in exam it is asked why some ionic crystals are colored. Ionic crystalline solids, they are colored, like KCl, potassium chloride, it exhibits violet color, and lithium chloride, this exhibits pink color, and sodium chloride crystal solid, it exhibit yellow color, and ZnO, zinc oxide, it exhibits yellow color. So why these ionic solids, they impart colors? There is some reason behind it. This is due to F center defect. This is the defect due to which the crystalline solids are colored. See, this is F center defect, or it is called metal excess defect. This is the defect in crystals. Here KCl, K plus Cl minus. So it is due to excess of K ions, and lithium chloride. This is pink color is due to the excess of lithium ions, and this is due to excess of sodium ions, metal ions. So this is called metal excess defect. Metal ions are in excess and they impart colors due to this defect. How it happens? How this defect is the cause of the color, which I will explain you little later. See, when KCl is heated in the presence of potassium vapors, this is heated in the presence of potassium vapors, and this is heated with lithium vapors. This is heated with sodium vapors. Then the defect arises in the crystal. How it arises? Let me take an example and explain it. Why the defect? Metal excess defect. See, this we have taken an example of sodium chloride, Na plus Cl minus. Then here this is the arrangement of the crystalline solids, which is shown by this diagram. This plus is represented as sodium ions, and minus is represented as Cl minus, chlorine ions. So what happens if we heat in the presence of sodium vapors? What happens? These sodium vapors, they collect at the surface and they are ionized as Na plus 1 electron is emitted. So there are many sodium ions which are collected at the surface, and what happens inside the crystal? The Cl ions, Cl negative ions, anions, they left this crystal, its crystal lattice place, and comes to the surface, and this it reacts with plus positive ion of sodium ion, and they make sodium chloride. And in the process, this electron This electron occupies the vacant place of this chlorine ion which has left its place. So here electron, these are unpaired electrons which have occupied the lattice place in place of anions which have left their place to form sodium chloride. So these electrons, unpaired electrons, they occupy the space, and these centers are called F centers. F centers. And see, here in the crystal there is excess of sodium ions because many chlorine anions have left the lattice, and hence there is excess of sodium ions in comparison with the anions. So there is a metal excess defect. And what does these unpaired electrons at F centers, these are responsible for the color of the crystalline solids. These are also the full form of F center is Farben-Genter. This is German. Farben-Genter centers. So these F centers, they are responsible for the colors of the crystalline solids. How? When visible light falls on the crystal, these unpaired electrons, they absorb energy, excitation energy, and in the process they absorb all the colors and reflect yellow color to our eyes, and we see a yellow color to the sodium chloride. So this is the reason why these crystal solids are colored, and same is the reason why this potassium chloride looks violet in the presence of unpaired electrons at F centers, and lithium chloride appears pink. Same are the reasons. So now I hope that you have understood that why these ionic crystals are colored. Sometimes it is asked in CBSE board exam. And before I finish this video, let me request you to subscribe to my channel. Thank you.